Okay, so we're doing desalination by distillation. We're going to show how people around the world that can't get fresh water because they live in desert areas, but they do live by oceans, can make water for themselves. And what we've got here is we made some ocean water. I made a little bit right here by basically just dissolving some salt in some water. And then we've got some regular old tap water. And I just want to demonstrate how we can tell if there's salt in there. So what I've got is some silver nitrate, and we're going to take some of this and we're going to put it into these two to see what we've got. The one on my right here is the salt water. The one on the left is the tap water. Okay, so if you guys are watching up close, you should hopefully be able to see this. So I can't get any out of the bottle. There we go. So going into the salt water, let's go into the fresh water first. Really not a whole lot going on there. See that? A little bit of white stuff forming. Not much. You can see some little white little drops happening there that are going through it. Let's try the same thing in the salt water. There's the salt water. Now watch what happens when we hit the salt water with this. We should see some very white, cloudy stuff. So what silver nitrate does is it precipitates into this white solid when it hits salts. Okay, when silver nitrate hits the salt that's dissolved in the water, it's going to form that white substance. Now you can see that our tap water itself, it's not perfectly pure, is it? It's a little bit salt. There's a little bit of salt in there. If we wanted to show some perfectly pure water, I'm going to have to rinse this back out again here. I think we've got some. Does somebody want to grab one of those little, is there a little squirter bottle anywhere? I don't see any. No, they should be clear. This one right here. Grab that little white one right there, that clear one. That should have water from it out of our still in it. Give me a rinse here. We're gonna rinse that. A little bit more, because I put tap water in there, so it might not be great. Okay, now put a bit in there. A bit more. And we're gonna try and hit this. So this came from our still in the back of our lab, where we actually do about the same process that we're trying to do by hand here in lab. Okay, that's good. We're gonna put a little bit in here and you'll see how cloudy it gets. It should not get as cloudy. Really, it shouldn't get cloudy at all. So that water is perfectly pure. Do you see how cleaner that water looks after I put the silver nitrate in there? So the silver nitrate did not form any solids in that. So this water has been completely desalinated, even more so than our tap water. Now what students have set up in lab is our setup here. We've got a flask up here that has salt in it, has salt water in it, and we've got it boiling with some heat down below. And as the heat heats up the water, it's gonna form steam. You can already see it happening here. The steam is gonna go up the tube, down the tube, and down into this next flask. And this flask just has the hose just poked into it here. We've kind of sealed up the entrance as much as we can. We have cold ice all around it. So we're trying to cool the hot steam that's coming down into this. And it should be starting to condense. We'll check back again here in a second. But as you guys look into your beaker, into the flask in your beaker with the ice, you should start to see some water developing, little droplets of water in the bottom of this thing. And if we did our job right, when we hit that with the silver nitrate, there'll be no solids at all. It will be just perfectly clear. Totally cleaned the water so it would be drinkable. Now we're not going to drink any of this, right? But we'll check back here in a second once we get to that point. Now we need to turn the gas off. So we've had a lot of boiling going on. The steam's been going up, it's been going down the tube, and it's been collecting over here as it cools in the ice water. So we're gonna turn the gas off here. So follow along with me here, guys. You need to be turning your gas off, okay? I'm gonna take this out. Guys, come on, follow along with me here. Turn your gas off. Turn your gas off. We're gonna put the ice in the sink. We can get rid of the ice. Yep, just turn the gas off. If you hold this over the sink while you take it out, can you guys hold that over the sink for me? Hold that over the sink. All the ice is gonna come out. Okay, so now what we've got here, we're gonna use yours, and Sam, if you've got a good one, we'll use yours too. Yep, be careful, guys. Don't mess with the one on the burner because it's hot, right? Don't mess with the one on the burner. Just leave that one. Cool. What we're after is the flask that was in the ice. And these ladies here have got quite a bit of water in there. So how long have we been doing this for, guys? It's been a while, right? It's been like 15, 20 minutes easy that we've been doing this for, right? And we look at how much water we've made. Is this a very efficient process?
No.
No, right? It is not an efficient process, but if you have no other way of getting clean drinking water, this works, right? So let's look through at some of the questions here as we go. Okay. Part one here. How should the contents of the cooled flask differ from the contents of the heated flask? Okay, number one there asks us, how should the contents of the cooled flask differ from the contents of the heated flask? What's going to be different about the cooled flask?
Shouldn't have salt.
It shouldn't have salt, right? The cooled flask, you guys are welcome to write the answers down as we go here. The cooled flask should not have salt in it. Okay, the cooled flask should not have salt in it. We are not going to do number two because that's about the other part. Okay, the cooled flask should not have salt in it. No salt. If you flip it over to the next page, we're going to look at number 4. We're going to skip number 3. Okay. Who can tell me what the process was? Okay, my phone quit on me. Let's back it up there a second, okay? Yes, you can use the restroom. Okay, so we said here that the cooled flask should have not had salt in it. And then we went over here to the next page and we were talking about what we actually used to desalinate it, okay? And it was desalination through distillation. That word is right on the front of your lab, desalination through distillation. We basically created a still. That was the answer to number 4 there. Okay, if we flip it over onto the next page, it's just the instructions. You can see what we did. Okay. We're going to skip this part B. So skip over to the next page and on to analysis and conclusions. We're just going down to question number 3 here. Okay. And question number 3 says, suggest at least one procedure you could use to demonstrate that the liquids in the heated flask, we didn't use the black bottle, and the cooled flask have different compositions. So in the heated flask, we had put a bunch of salt in there, right? So it should have salt. What can we do to test that this new flask that we condensed it in doesn't have salt? Well, the same test I did at the beginning. We used this stuff called silver nitrate. And I'm going to write that down here for you. Test with silver nitrate. Chemical formula AgNO3, if you want to write that. Okay. Okay, and it will, if salt is present, it makes white precipitate. Okay, if the salt is present, it's going to make a white precipitate. So we're going to test it with silver nitrate. So what we're going to do is we're going to test these two. Good, you got quite a bit in there, Sam. Let's test yours too. Here we go. So this is the material we condensed compared to the material that had salt in it. Let's grab one that had some salt too. Hopefully it's cool enough. Can I touch it? Oh, it's pretty warm still. So I'm going to try and get it in here. Hey, Mr. Lynott, you got a spare hand for a second? Would you mind holding my phone for me here for just a second? Can you just record that for me real quick? It's already running there.
Okay.
Okay. Get this off of here without burning myself. There we go. Okay, so this is the one that we were boiling. If you don't mind holding it for just a sec here. Thanks. And this is what we collected. So we're going to test these two with some silver nitrate. Now, one with salt in it should form a precipitate. Once this hits, you got it down there. There we go. You should be able to see those drops going, whoa, really white. Now let's try the same thing with Sam's water here. I'll tip that a little bit so we can see. There should not be salt in this, hopefully. Yeah, look at that. So very little. There was probably a little bit in the flask already, but very little in comparison to that other one. So we did a pretty good job. We'll test you guys here, see how yours did. Anybody else want their water tested? See how much salt they cleaned out of it? Oh, something went wrong there. Oh boy. So we didn't get to really clean water here. But that was the idea, was to get desalinated water through that experiment. And we just tested it, and it worked in some of these. Anybody else want theirs tested? Okay, I got it, thanks.
Sure.
Okay, so let's look at the last question here. Flip over to the very back side. Okay. This is an important question here, okay? Even though desalination of seawater is used along some coastlines today to provide fresh water, there are some disadvantages to this process. List a couple of these, okay? So, first of all, you guys told me, what was one disadvantage? You know, because we sat down here and did it.
Slow.
It was slow. This is a slow process. It takes a lot of time. How about in terms of energy compared to, say, pumping it out of the ground? How much energy do you think it takes to heat this much water? A lot of energy. Those are the two biggest. I'm trying to think of a third. Can anybody think of a third? You say, pull that up, please. Can anybody think of a third? Other than the fact that you don't get very much, you don't make very much, that's probably another one there. Oh, well, here's the other one here. The cost. It's very expensive. Doesn't make very much, requires a lot of energy, slow, it's expensive. So those are all the reasons that desalination is not used widely any place where there's any other source of water. Okay, but it does work. Okay, so you're ready to take your quiz. It's on It's Learning. After you've got all these answers filled out, you should be able to do that.